Welcome back to Math with Miss Reimer. Today we're looking at section 7C, which is multiplying binomials. Remember, binomials have two terms, and we're going to use the FOIL method. So it's first, outer, inner, last is the pattern that we're going to multiply with. So this is similar to distributive property, which you'll kind of see as we get through our examples here. So our first terms will be x times x to give us x squared. Our outer terms, or the two outside ones, give us 4x. Inside terms give us 2x. And our last terms then is 2 times 4. When you have a power of one variable and a constant, the two middle terms in both sets will normally be able to be combined. So in this case, they can here. We're going to see the same thing in our next example. We'll do y times y squared first, y times 1, 5 times y, and then 5 times 1 here. And our middle two terms are the same, so I can combine them by adding. The key here is that everything from the first set of parentheses gets multiplied by everything in the second set of parentheses, and the FOIL pattern helps us make sure we don't forget anything. So in number 3, we'll go x times x is x squared, x times negative 2, 5 times x, and then 5 times negative 2. My middle terms they're like terms, so I can combine them. So negative 2 and 5 will give me 3x. There is another way to solve problems like this called the area model that I just want to show you so that you can see that it's a thing. And you take each piece of your binomial and you put it on the side of rectangles that are same amount. So a 2 by 2, because we've got 2 by 2 here. And then we will multiply each piece. So x times x will give me x squared. Negative 2 times x will give me negative 2x. X times 5 will give me 5x. And negative 2 times 5 will give me negative 10. In this case, I can combine these two terms together. And notice that these are the same pieces we're looking at here, and we get the same final answer through here. So this is using an area model, and it looks just the same as, it comes out just the same as if we actually multiply. If you haven't already done Punnett squares in science class, when you do them, Punnett squares work really similar to our area model. So let's keep running some examples. So our first terms, remember when we multiply, our exponent changes, our outer terms, our inner terms, and our last terms. Remember, once we've multiplied everything out, then we're just combining like terms. So these two, the variables don't change at all. We just combine the positive 8 with the negative 1 to give me positive 7. And notice that this is in standard form, so my x squared is first, x to the first, and then the constant at the end. Follow our FOIL pattern again. W times w is w squared, negative 3w, negative 2w, and then a positive 6 at the end. These two can be combined, so negative 3 and negative 2 give me negative 5w, and then we bring down the front and the back. The same thing applies regardless of what the signs of your binomials are. So x times negative 4, negative 10 times x, and negative 10 times negative 4 is positive 40. And then we can combine these two, and we will get negative 14x plus 40. In number 7, when we start to see coefficients in front of our x's, the process still applies the same way. So 2x times x is 2x squared. 2x times negative 5 is negative 10x plus 1x minus 5. These two are still the same terms, or they're like terms, so I can combine them. So that will give me negative 9x minus 5. Again, x times 5x is 5x squared. X times negative 4. So that's taken care of multiplying this first term by both. Now we'll go second term by both. These two are like terms, so I can combine them to be negative 9x. There we are. Now, in number 9, you're going to see that we've got two sets of variables, but the process still works the same way. So 2a squared, negative 8ab. The a's and b's can't be combined, so they just come to sit together. That's b squared. And then these two terms are the same, so I can go ahead and combine them, negative 3ab. Remember, even if I had written one of them as BA, it's still the same because of the commutative property, so we can still put them together. In number 10, when we add more coefficients into our piece, we get 28x squared negative 8xy plus 7xy negative 2y squared. Our middle terms both have an xy in them, so we can combine them. Remember that although our front and our back term both have a squared term, it's not the same variable squared, so because of that, we cannot combine them. Now, number 11, we start to see a pattern that's going to be a little bit different. So we get x squared still. The process is still the same, but we're going to notice that our outcome is a little bit different. What do you notice right here is going to happen when I go to combine my middle terms? You should see that we've got a negative 2x and a positive 2x, so both of these are going to cancel out, leaving us just with x squared minus 4. This is called a difference of squares pattern, and it's when you have the same binomial except for one is plus and one is minus. So when you multiply them together, those middle terms will always cancel out. For instance, in number 12, we'll get y squared, positive 6y, negative 6y, and negative 36. And again, my middle terms will cancel out, leaving me just with y squared minus 36. So when you see a difference of squares pattern like this one, you know that actually it will simplify to this term squared plus this term squared. Notice the same thing happened here. That's 2 squared, that's x squared, and then 2 squared is 4, y squared, 6 squared is 36, always with a minus in the middle. So when we multiply these ones out, we'll get 9x squared minus 3x plus 3x minus 1. Again, our middle terms are canceling, so we get 9x squared minus 1. Again, this piece is the square of that, and this piece is the square of that, and it's always minus. We will spend a lot of time with this pattern when we start getting to factoring as well as we continue on in the chapter. In number 14, we've got more variables, but still the same pattern that's going to pop up. So we get 4r squared minus 2rs plus 2rs minus s squared. And then our middle terms cancel again, and we are left with 4r squared minus s squared. And again, notice that if I square 2r, I get this. If I square s, I get that. Difference of squares pattern. And the last special pattern we're going to look at here is the sum or the difference of a binomial. So if you start with something like this, x plus 4 squared, what you actually need to do is take this and multiply by itself twice. So it's actually x plus 4 times another x plus 4. We talked about this when we did exponents because we weren't allowed to bring that 2 in when there was a plus or a minus, and this is why. Because actually, you've got to multiply 2 of them together. And once you have them written out, you multiply them the same as we have been with our FOILing, but we've got to have both of them. If I just bring those squares in, I end up missing that 8x part in the middle, which is why you can't just bring that square in, you need that 8x part. In number 16, this is actually 2m minus 5 times another 2m minus 5. And so when we FOIL again, do all of our rainbows, I've heard them called, 2m times 2m is 4m squared minus 5m. Nope, that's not right. Minus 10m, that's better. Minus 10m again, plus 25 at the end. Combine my middle terms, and we will get negative 20m plus 25. In number 17, again, we are squaring this piece, so we're actually doing a plus 3b times another a plus 3b. And when I multiply those through, I'll get a squared positive 3ab. I know another positive 3ab is coming. And then my last one is plus 9b squared. Combine your middle terms, and you'll get a squared plus 6ab plus 9b squared. One thing I do want to take a quick look at is this piece right here. This is the algebraic way of describing what's happening in 15 through 17, that if I square a binomial, I always end up with the a term squared at the front, the b term squared at the back, and then a, b, there's 2 of them. So for instance, we can look at 15, we've got the x squared at the front, the 4 squared at the back, and then I take 4x together, and we get 2 of them, and that's where your 8 comes from here. Same thing with your minus pattern. We square the 2m, we square the -5, and then 2m times -5 is -10, and there's 2 of them, so that's where you get your -20. You don't have to have these memorized at all because they just show up as you do your foiling, but just know that this pattern does exist in how sum and difference of binomials work. The last thing we're going to look at today is multiplying a binomial by a trinomial. It pretty much does the same thing as the foiling, we just add an extra term into one of our polynomials. So we take the x, we'll multiply it by everything in the second one, we'll take the 4, multiply it by everything in the second one, and then combine like terms. We just have a few more terms to play with here. So x times x squared is x cubed, x times 3x is 3x squared, then we get -6x, 4x squared, plus 12x minus 24. Now we're going to go collect all of our like terms. So I've got an x squared here and here that will go together, and then I've got an x term here that will go with this x term as well. We're going to write our final answer in standard form, so that means that our highest exponent needs to go first, and then we will go down the line from there. So we'll start with our x cubed, and then x squared, x, and then the constant always wraps us up at the end. So in number 19, we'll do k times k squared to give us k cubed, negative k squared, negative 8k. So now I've multiplied the first term by everything in the second, and then we'll do the same thing for the -5. It becomes positive 5k, and then lastly positive 40. So then again, I can combine my like terms. So I've got just the k's here that'll go together, and my k squareds. Remember, we always take that sign in front of the term, and it's a part of it. And again, we're writing in standard form, so I start with my k cubed, then my squared, then my k, and then lastly my constant at the end. One last one, we'll take 2x times 4x squared, and that'll give us 8x cubed. Multiply again, that'll give us -6x squared, -12x, and then our 2, -6x, -12. And then again, combine your like terms. So we'll get our x's that will go together, take the signs in front of them. Our x squareds will also go together. We'll take the signs in front of them. And then again, we'll write in standard form. So we'll start with our x cubed, go to our x squared, just x, and then our constant at the end. And then for our last one, our geometric application, we need to find the area of the shaded region. So we need to find the area of the outside, and we need to subtract it from the area of the inside, or the part that's not shaded. So to find our whole area, we first need to find the area of the outside, so that'll be the 9x minus 2 times 2x plus 7, so that's the outside, and we need to subtract it from the area of the inside, so 3x times x plus 12. So let's do some simplifying first. So we'll FOIL this first part. So that will give me 18x squared plus 63x minus 4x minus 14. I'll go ahead and combine these. Get 18x squared plus 59x minus 14. And over here, while I'm distributing this one, I'm going to take the negative 3x squared and negative 36x here. So now this is my whole area string now that everything's been simplified out of parentheses. And so now I can combine like terms. So I've got 2 squares, which will give me 15x squared. I've got a total of 23 x's, and then the minus 14 is still my constant. So that is our final piece of area. 5 things. You are lovable, valuable, changeable, forgivable, and never alone. I hope you're confident in the math. I hope you feel like you know what you're doing more than anything else. I hope you know that I care. Thank you.